So now let's take what we learned in previous sections about graphing straight lines, and let's add to that this idea of linear inequalities. So the way to think about this is we'll have a straight line. Let me just say that we graph a straight line here, and we learned how to graph straight lines in our previous sections. And the only thing that we're going to add to this idea is by adding these four different symbols, it's going to indicate whether we shade above the line to indicate that we want to have all the values above a line, or if we shade below the line, which is all the values below the line. And then we'll get into the details about this, but for ones that include this or equal to line, as you see here, this line here, or this line here, in those cases we'll use a solid line. But if you ever see just the symbol without the line, like these ones, then for those ones we will have a graph that is dotted line. Now, I'm going to get much more detailed as we actually go through the notes. This is just a general overview to kind of help your mind focus on the distinction. Previous lessons, we learned how to graph straight lines. Now we take that knowledge and we extend it a bit to the idea of inequalities, where based on the symbol used, we'll either shade above or below the line, and based on the symbol used, we'll either use a dotted or solid line. Now, more information about all of that is coming up, so let's go over this little by little, but that's our quick overview of what's going on in these notes. So a linear inequality is going to be written in this form, and what I want to draw your attention to is these A, B, and C that you see in these four lines. That's just representing some number. So A, B, and C are representing generic numbers. The focus that I want you to have is that this structure in each equation is basically a line. The only difference comes from these symbols. Had these symbols, what I have highlighted here in blue, been replaced with equal sign, then this is no different than the straight lines we've covered in other sections. The difference comes from the fact that we use these symbols, which I'm going to read off one by one here. This first symbol should be read as less than. This symbol is less than, and if you notice, it seems similar to the above symbol, but it has that extra line. That extra line stands for or equal to. This one, greater than, and then this one is greater than or equal to. And again, it's the or equal to because of the line that accompanies it. And our goal of this section is to graph these inequalities. So one of the first things that you'll want to focus on when it comes to graphing these is, are we using a dotted or solid line? You'll use dotted lines when it's not or equal to. So for just a strictly less than or strictly greater than, these kind of equations will use dotted lines. But if you have the or equal to line, as we do in the second and fourth, that's when you're going to use a solid line. And the difference between a dotted or a solid line, a dotted line means don't include the line itself. A solid line means include the points on the line. So it's like we want to include either the points above or below the line and the line itself if it's a solid line. That represents the or equal to. So in graphing these linear inequalities, we've got 3 steps to follow. And the good news is the first step is just do what we did in previous videos. I encourage you to, in your mind, replace the inequality sign with the equality. So this is just kind of a imagine. Don't actually write over it because you do need to see what was originally written, but just imagine in your mind and then graph the line following our previous notes. And as a quick reminder, whenever we're graphing a straight line, we kind of talked about 2 ways to do it. We could either find the x and y intercepts, or we could graph, if it is in the slope-intercept form, by using the y equals mx plus b, seeing the slope, and seeing the y-intercept. Now, just as a reminder, this is definitely the faster way, but it only works if the equation is given to you in y equals form or if you algebraically um, rearrange it to where it's y equals. This will work no matter what, but it is slower. So once we know how to graph the line, then the new information comes from focusing on the inequality. Now, inequality just means these symbols. And it's what's going to be written in place of the equal to sign. So if you see that we have a symbol with the line under, that's a or equals to line. So this is a less than or equal to. This one's a greater than or equal to. That's when you use a solid line in your graph. If you see it's just the less than or greater than with no line underneath, that's going to be a dashed line or a dotted line. And then again, looking at the inequality, you can tell whether we're going to shade above the line or below the line. If we have y equals, or sorry, y is greater than, or y is greater than or equal to, that's when we shade above in these two circumstances. If we instead have y is less than or y is less than or equal to, that's when we shade below. So just looking at the inequality, we can at the beginning know should it be dotted or solid and should I shade above or below. So for example, in our next example here, it says graph this inequality. I would read this as y is greater than x plus 2. And because of this greater or this greater than symbol, I know immediately since there's no or equal to line, I should use a dotted line or dashed, just depends how you like to think about it. And let's think, should we shade above or below based on the way this is written? This matches this scenario, so we should shade above. So I'm just going to remind myself I shade above. And now, looking the way the line is, I'm going to do step 1 and say, imagine there was an equal to sign. So off to the side, I'm just going to imagine there's an equal to. This is in the perfect y equals mx plus b format. This matches this one, so I'm going to do that quickly. Refer back to our earlier videos if you want a review of this. Because there's no number written, that's an implied 1. So that means our slope is 1, but we know slope is rise over run. So in any case, if you want to make it a fraction, you can always divide it by 1. That doesn't change the value. You can check that in your calculator. The b, the y-intercept, we see is 2. So whenever we graph this, let me draw my y-axis, my x-axis. So it hits the y-axis here, up 2. And then the rise over run says you need to go up 1 and then over 1 to get your next point. And then you go up 1 or over 1 to get your next point. Now, because it's a dotted line, I should connect these with a dotted or dashed line all the way back. And then because I notice I should shade above because it's this y is greater than symbol, I'm going to shade the region above, which is all of this region. So I'm just going to kind of shade this in here. If you don't have a color, you can just shade with your pencil. And the solution to this inequality, the way these inequalities work is it says any coordinate point in this region will satisfy this inequality. It's not that there's just one solution, it's all of these could work as solutions because we just want to be greater than this line. Y needs to be greater than this line. So let's continue working through graphing inequalities following our 3 steps. We remember the first step is to just replace it with the equal sign to help us think about the graphing. And this goes back to our previous notes. If you need help with graphing straight lines, go back to our previous videos where we go through it more in depth. I notice that I have the or equal to, so I'm immediately making a note off to the side for step 2 that I'm going to use a solid line. And because it's y is less than or equal to, notice the orientation of the arrow, I know I need to shade below. I think it can be helpful to make these 2 notations before you even start graphing because once you start working, it's easy to lose focus. While you're clear-headed, write down based on what the symbol looks like, is it dotted or solid, and should you shade above or below? And again, the indication of those is earlier in our notes. You can go back and review that. So this is nicely set up again in the y equals mx plus b format. So I'm just going to record the slope is -3, which when it comes to graphing, we know we want it to be a fraction, so we can think of rise over run. So that's going to be -3 over 1. My y-intercept is 1, so let's draw our y-axis, our x-axis, draw the little two vertical and horizontal lines intersecting. My y-intercept is going to be up here at 1, and now it says you actually rise by -3. Rise by -3 is say go down 3, so go down 1, go down 2, go down 3 to go over 1, and that will get you to this point. Now these red lines I'm drawing in are just to help us visualize. You can just do that in your mind's eye. You don't have to actually write it. So go down 1, go down 2, go down 3, go over 1. It'll get you this next point. Now we know we should do a solid line, so I'm going to connect these with a solid line all the way down. And now that I've found these, I'm going to erase these little guiding points to make it easier to see. And I should shade below because its y is less than or equal to. So I'm going to shade everything below the line. So we can find our solution. Our solution to this inequality is anything that lives in this shaded region, or since it's or equal to, on the line. So we're shading below the line and up to the line. And not everything has to be shaded perfectly. We're just getting the idea that we want this lower section. So here I just included again a helpful reminder. We saw something similar to this earlier in the notes. For lines that are of this format, y is less than or equal to, you shade below. If it's y is greater than or equal to, you shade above. And what you're looking at here is the difference between how the symbol is oriented. So that's what you're trying to pay attention to here. So let's graph this inequality. And I'd encourage you to pause and attempt this one on your own, and then unpause to check your work. Now here, remember, we covered graphing these kind of lines in an earlier section. So remember our three-part step: graph it as if it's a regular line, think about whether it should be shaded or dotted based on the inequality, and think about should we shade above or below the line. So based on the inequality, I'm going to see, since it's a or equal to, I'm going to use a solid line. And y is less than or equal to, so I need to shade below. Now, if I was just to imagine this was the line y equals -5, what I did here is I replaced the inequality with the equal sign. I would see this matches what we've seen in our earlier notes. This is a horizontal line. If you're not familiar with this, go back to our previous notes or videos and see the section where we covered graphing horizontal lines. But I know horizontal lines will be, this is my xy axis, it goes down to -5, -1, -2, -3, -4. I need to extend my graph a little. Here at -5, and it's going to have a solid line here, all the way down -5. Actually seeing this, since I can erase, let me rescale it since we're almost running out of space. I'm going to make my axis smaller. So I'm going to start up here, and this will be a -1, -2, -3, -4. I'm just trying to get it to fit on our page. -5. So I'm drawing my solid line. And because it's inequality and we're less than or equal to, I need to shade up to the line and below. And that would be the solution to this inequality. Now, if we continue with our next example, I immediately notice it's dotted line. And based on the orientation, previously all our answers worked with if y looks like this, right, we shade below the line. Or if y was in this symbol or this symbol, we shade above the line. But we haven't covered what to do with x and the symbol. With x and the symbol, it's a little different because we know the equation x equals 5. That's actually a vertical line. So above the line or below the line doesn't make so much sense here. Let me just draw it really quick so we can see. X equals 5 is a vertical line. 1, 2, 3, 4, 5. And now that we graphed it, we can see the idea of above or below the line doesn't make so much sense. A vertical line doesn't separate the coordinate axis into above and below. Instead, it separates the axis into left or right. And that's where we need to update our rules because our rules are correct for when y are these symbols, do above and below. But when it comes to x, we actually need to add in more rules. If you have x in this format or x in this format, then you shade to the left because you want to be less than the value. X should be less than, so you should do x values less than. Shade to the left. If instead it's this format, then you shade to the right. So shading to the left or shading to the right is kind of the translation of shading above or below, except now we're in the vertical line, so we're talking about left and right, less than and greater than. For other lines or horizontal lines, we can talk about above and below because that's greater than or less than. In both cases, it's dealing with understanding the inequalities being less than or greater than, and then just translating that based on the actual line. Is greater than or less than based on the context, is that above or below, or is that left or right? So keep in mind these ideas, things of this format below the line, this format above the line, this format to the left, this format to the right. So based on that, if it's x should be greater than, I know I should shade to the right, which means I'll complete this graph. And actually here I realized I made an error. Perhaps y'all have caught it. Do y'all see that this is a not a or equal to, but yet I've done a solid line? So let me erase my work. So focused on drawing the line, I did not make it a dotted line. So that's a detail. This needs to be dotted line because it's not or equal to. And then I will shade to the right. All the points to the right of the line are the solutions to this inequality. So my answer is this shaded graph with the line. So with those last examples, we've had some practice with graphing these inequalities. And the difference in those problems is they're just going to be different inequalities in lines, but the basic structure is always look at the inequality, figure out should it be dotted or solid line, above or below for y lines, left or right for x lines, and then correctly shade it, draw the line like we've covered in our previous notes. Now we're going to add another layer to it. Y'all saw in a previous section, we talked about systems of linear equations, so we graphed two lines intersecting together. Now we're going to take what we know about graphing intersecting lines and what we now know about inequality shading to the right section, above or below, left or right, and we're going to layer that information and we're going to talk about systems of inequalities. So the steps for dealing with systems of inequalities, and how do you know you have that kind of problem? Well, you'll see something like graph this and we have our bracket to tell us it's a system, and instead of equal signs, we've got inequalities here. So that means we need to not only graph the lines, but then shade appropriately. So the steps are, step 1, graph the lines on the same coordinate axis. Keep in mind that we use solid lines for these types of inequalities, dashed lines for these types. And then you shade appropriately. And then to find the overall solution, you combine the graphs, you look at where the regions overlap. The overlap shading is the solution set. And I'm going to try to show you in our video how we can draw it and make that clear to us. This is particularly best if you're working with a pencil, because whenever you shade with a pencil, if you shade over the same region, that region that gets shaded over multiple times does get darker, so it'll be more visually clear. So if you do have a pencil, pause this video and go find it. That will be very helpful with this. I'll also try to show it here with colors. So here we're asked to graph the solution set of this system. Now, the first thing that I want to do is I'm going to try to make sure the lines are in a way that I can graph them without too much trouble. I could graph this using the x and y intercept method because it's not immediately of the form y equals mx plus b, right? It's not solved for y. But I think it wouldn't take that much effort to solve this to get y by itself, and then that's a lot faster in graphing. So let's actually solve this to get y by itself. So just to make this easier to work with, I'm going to temporarily just put the equal sign because that's what I'm used to manipulating, but I do know it's going to keep this symbol overall. This helps me determine left or right, dotted or dashed. So I'm going to subtract x from both sides right now. My goal is to do algebra to get this in the right format where I can quickly see, so this will be in minus x plus 4. Now it's in y equals mx plus b format. The slope is a -1, which I can write as -1 divided by 1. The reason I'm doing that is if you divide anything by 1, it's okay, but then it helps me see my rise over run format. My y-intercept is 4b. Now this second graph, maybe I'll write it in blue to keep things distinct. If I get rid of the inequality to help me see it as a graph, then this is in the y equals mx plus b format. Remember, if there's not a number written in front of the x, it's an implied 1. So m equals 1, which would be 1 over 1 to help me see the rise over run. And the b, there is no b. There's no number. That means the b is 0, because plus 0 just goes away, right? Plus 0 is nothing. And then before I get caught up in graphing, I'm going to look at the inequalities and write down what it tells me. The first one, having this or equal to line, tells me I should use a solid line. And since these are both y inequalities, I know I'm thinking above or below. So the inequality, if I rewrote it, would be y is less than or equal to negative x plus 4. Looking at that inequality, y is less than or equal to, I know I should shade below for the black line. For this line, y is greater than or equal to, let me write this in blue. This inequality tells me I should use, again, a solid line, but greater than tells me I should shade above. So let's draw our coordinate axis and we'll start graphing these. So there's my x-axis and my y-axis. For the first graph, I'll graph it. It says it has a y-intercept of 4. And then the slope is a down 1 over 1. So it rises by going down 1 and running over 1. Down 1, over 1, down 1, over 1. Keep doing this till you have enough points that you can make a good straight line. Now it does have a solid line, so I'm going to draw that solid. Okay. And then I need a shade below. So this is where if you have a pencil, it will be particularly, I think, easier to work with because you can see the overlap shading better, but I'm going to shade everything below here. So that takes care of the first line. Now let's graph the second line. So at the second line, I'll graph it in blue. It said it had a y-intercept at 0. So it hits right at this, is called the origin, where the two x and y-intercepts cross. And my slope is up 1 over 1, up 1 over 1. Oh, we see a nice intersection here at the point 2, comma 2. Up 1 over 1. And we know we should do a solid line. So I'm going to connect those through a solid line. And now it comes to shading above or below this blue line. We already wrote from before the way the inequality is written, we're shading above. So let me now shade above. So now I've shaded above this blue line, and my overall solution is where they overlap. So it's where they overlap is where we're interested, and I think we might be able to see it here if we look closely. Do y'all see that it's a lot darker color blue here where my shadings overlapped? And I think it will show that for you too if you did a pencil. If you did a pen, I don't think the difference in the overlap will show as clearly, but if you did a pencil, it should show up. So this region here, I'll try to outline it with this, shows the overlap section. So our entire solution is this region that I'm highlighting here. And if we want to make that more clear, we can come over and shade it again to try to make the distinction clearer that our solution is just this overlap section. So particularly if you're looking at a quiz where it asks you to graph this, then likely you'll see answers provided for you. My suggestion is that you work the problem on your own first. Don't even look at the answer choices. It's very easy to get distracted by small details if you're looking at already provided solutions. The best thing is for you to do your work yourself, and then once your work's done, compare it to the answer choices. And when you're looking at the answer choices, be careful to notice the distinction of where one's darker or lighter. The darker the shading, that indicates the overall solution. So just to clarify again, this entire region that I'm highlighting in red, this is our solution because it's darker shaded. So this is our last example of this section, and it asks us to graph this solution of inequalities. As a quick reminder, what you're going to do is you're going to figure out how would you, first you're going to look at these inequalities and make your notes should you be shading dotted or solid above or below based on how it's written in this Y inequality format. Then you're going to figure out how would you graph the lines individually and graph them one by one and then shade appropriately. The overlap of the shading is the solution. So why don't you pause the video right now and attempt this on your own. And then when you're done, unpause and you can check your solution step by step with my solution. Now the first thing I notice is these inequalities are written in a very nice format for us. They're both y inequalities. They follow the y equals mx plus b format, which means when it comes down to graphing the line, I can quickly notice what's the y-intercept, what's the slope, and that will help me graph this very fast. But before we do that, and we get too much in the weeds of graphing the lines, let me look at these inequalities and make a few notes about it. Do we see this or equal to line? That means you need to use a solid line when you make the line. And because it's y is less than or equal to, I know I need a shade below. And I'm going to write the first one all in black. We'll do blue for the next one. Because there's no or equal to, I know I'm going to do a dotted line. And because it's y is greater than, I'm going to shade above. Now let me write out the details of graphing this. For this one, it's going to be y equals 3x. That tells me my slope, my m, is 3, which I can write as 3 over 1 to help me see my rise over run. The y-intercept, there's no plus number. That's implied that the y-intercept is 0, because plus 0 just doesn't have to be written. My blue line would look like y equals negative 2x plus 4. Well, that tells me that my slope is negative 2, which I can write as a fraction as negative 2 over 1, because dividing by 1 does not change the value, but it helps me clearly see what's the rise, what's the run. My y-intercept is 4. So let me begin to graph these. Okay, so the black line will be the first one, and it's a y-intercept of the 0, so it hits at the coordinate axis point, the origin, and I need to go up 3 over 1. So let's think up 3, 1, 2, 3, over 1 will get me to this point. And I know I need to do a solid line for the first one. So I'm going to draw this with a solid line. And I know I need a shade below, so I'm going to do that now. Now that I've finished graphing the first inequality and shading it as appropriate, I'm going to do the second. So let's find, we know our y-intercept is up at 4, so 1, 2, 3, 4. So up at 4, we have our y-intercept for the second inequality. And the slope is a negative 2 over 1, so that means you go down 2 to go over 1. So I'll be here, down 2 to go, down 2 to go over 1 will be here, down 2 to go over 1. I'm just making enough that I can easily draw this. And I noted it should be a dotted line, so I'm going to be careful and connect these with a dotted line. What the dotted line indicates is that the line itself is not in the solution. And it did say we should shade above. So now let's shade above this line. And when I shade above, I can see this overlap. This section has become a darker color because it was shaded for both inequalities. It is the overlap. And again, a reminder that will probably show up best if you use a pencil, but you're looking for where did they both overlap. We had to be below this line, but above this line. Their only intersection is this region here. So you can find the overlap by seeing which one's darker shaded, or by kind of explaining them both together and thinking where's the overlap. Below is all of this one, above is all of this one. The only place that they overlap is in this region here. So just to make it clearer, this region here is the overlap. And we'll be looking for that visually if it's provided for us as which region is shaded darker. So as always, if you have any questions, please do let me know. I'm very happy to help. Just reach out to me via our campus communication, and I'll be happy to discuss these problems with you. I hope you have a good day. Goodbye.